Actually, before I start the lesson, I'm going to go over one of the homework questions yesterday. What number is that? On page 262. There was number 5. I want to go through that one really fast. So it's important with these ones that you think about the angles involved. So for number 5, you have people lifting upward, right? It says the ropes make an angle 15 degrees with the vertical. So the vertical is just a straight line up and down. And the ropes Everybody good? You all good? Hi. You all good? Is everything okay? You're depressed about what? Right. Wait, what? Bullying you? Wait, a painting of Jesus?
Have you ever seen
Miracles from Heaven? Heaven is for real. I read the book, yeah. Oh yeah, I've seen that painting, yeah. That's amazing. That is, I don't know. I can look it up later if you remind me, but I have no idea. That's really cool. I didn't know. All right, let's get to class, and should be a short lesson today, but I want to go through the homework number 5 really fast before we go on to the lesson. So this would be what the angle is. When they mean with the vertical, that's what they're talking about. So there are a couple of things you could do to answer this question. One thing you could do is this. You could make a horizontal line and think about what is the angle from here to here. So what would that be? 75 degrees, right? So you could do this. You could use sine of 75. That could work for this question. So that would be one example of how you could solve that problem, would be using sine of 75. Or you could just turn it on its head and just have it where this would be a horizontal line straight up and down. You can use cosine of 15 degrees. That could also work. Why would you use sine? Well, you could because it's a vertical movement, right? So we're dealing with the angle. Yes, right there. You could use sine if you have a vertical. Thank you. If you are looking at the vertical, which is what you are in this case. Cosine is for the horizontal, right? So you could use cosine of 15 degrees or sine of 75. You could use either of those ones. Either of those will give you the right answer for that. Does that make sense? So either one would work. Everything else for the homework yesterday, that all makes sense? Was it straightforward? Okay. So yesterday we talked about how you need to apply a force in the same direction as motion for you to do work. And so if you have a box on a ground and you want it to move this way, its velocity is that way. But you apply a force in this direction. No. Probably Michael, Van Mickle. It sounded like him, you know? You don't think so? Who would that have been? That kind of sound like him. I don't know. It's not Carl. He's not here. Bauer? Yeah, I can see that. Listen. Wow. Okay, so if you were to do this, what is the angle that you're applying the force in? What angle is your applied force? Yeah. 90, that's right. So because you're going from the horizontal, so it's 90 degrees. So your angle is 90 degrees. Remember the equation for work? Work equals force times displacement times cosine of theta. Well, we're going to put it 90 degrees. What is cosine of 90? 0. Cosine 90 is 0. So work is 0. That's why this mathematically tells you why work is 0 when you apply a force perpendicular to its motion. That's also why we say the sun does no work on the planets, because the sun pulls perpendicular to the planet's orbit. It applies a force on the planet that's on the direction of its motion. And so the sun does no work on the planet.
If you have someone as heavy as the force, as the velocity,
Somebody as heavy as what now?
the velocity, horizontal force.
So somebody as heavy as the horizontal force. So like you have this person right here, and so he has a weight of say 120 pounds, and you have a horizontal force like this of 120 pounds. Is that what you're saying?
Yeah.
So those are in 2 different dimensions, right? Yeah. So you could definitely apply a force of 120 pounds on somebody, and they could actually just stay still. They actually, if they're strong, you could push against somebody with all your weight, and they would just stay in place. That is a possibility. Why is that? Well, they can apply more force than 120 pounds. This downward force is what they can apply on the ground. So they apply this downward force onto the ground of 120 pounds. But this person, because of their muscles, because of friction, they can apply a lot more force that way. Or upward. Like that's why people, can bench press more than they weigh. They can lift up things more than they weigh. People can apply more force than they weigh in different dimensions. No, so they can only, by their weight, can only press down with this much force, but they can lift up or push against something with a lot more force than their weight because of their muscles, because of friction. Yeah.
So in bench press, you are in the same dimension
as your weight. That's true, but you are in the same dimension. So you are doing work scientifically, but you're using your muscles, you're using your bones to apply an upward force, right? You're not using your weight. If all you were doing is using your weight to press downward on something, then all you can do is 120 pounds if that's what you weigh. But for bench pressing, you're just doing the opposite. You're trying to lift up, which means you're using friction, you're using your bones, using your muscles to apply an upward force. That's true. If you jump, then you would be applying more force than your weight. That's right. Yes. You have a question, Robert? Well, you would know based on where whether it falls in or not, and so it depends upon where you are. So there are some places it does break. I mean, so have you ever heard about sinkholes before? Have you heard of it? So if you have the ground definitely has holes in it. So there are places in the ground that are hollow. So you actually could have below the ground this huge hole that's right below the ground, and you don't even know about it. And let's say you build your house on top of that hole, and then the earth just, over time, the earth just, because of cars along the road, because of earthquakes, the soil moves. You could have this open up, and your house just caves in to this giant hole. Not very common, but it does happen. It's called a sinkhole. And so there are places where the ground is hollow. But do I know? Yeah, I mean, there is definitely a limit to how much Earth can hold. It's just that we can't get any close to the limit because we're like dust on top of the top of the table. The dust particles are just so small, it doesn't affect the table. So that's even buildings. So even buildings are like specks of dust on the table. So Earth is like the table, and the specks of dust are like buildings. Like the tallest thing we can build in mountains. We can measure it. It's just that it's just so big. It's not going to be practical for our daily life because we can't anywhere close to that amount. We can have nuclear bombs that won't do anything to the Earth at all. I mean, Earth is just so big compared to those things. So yeah, there's a number. It's just such a big number. It's not going to be something we can even like imagine. It's just so big. So. I mean, you could get everybody in the world, about 8 billion people in the world, to be in one place in the world and all jump at the same time, and the Earth would do nothing at all. I mean, there'd be like no effect at all on the Earth. It would. So, even the buildings. Well, okay, so there'd be earthquakes, right? You can get a rumbling, you can get an earthquake, but as far as like the Earth actually changing, that's what I meant, like changing its course, changing its speed, changing its shape. But you're right, you would definitely be able to feel a rumbling in the Earth if it was big enough. You'd hear something, you hear a noise, you'd feel a vibration. That's definitely true, yeah. It wouldn't do anything to the Earth. It wouldn't. I mean, it would slow it down to a point you could measure, but not a point you actually would feel any difference. It'd be hard to do that. Okay, let's move on to a new concept today, power. So power is the rate at which an external force changes the energy of a system. So that's one way to define power. Another way would be to say, how quickly is work being done? The rate at which work is being done. So those are two definitions of power. They go along with each other. But in an equation form, power is equal to work divided by time. So it's just simply how quickly can you do something? That's what power is mathematically. It's units for power. So power is work over time, right? What unit do we use for work? How do we measure work? Joules. So the units for power would be joules over what? Joules over what unit do we use for time in science? Lauren? Seconds. So joules over seconds. So a joule per second is the same thing as a watt. So you've seen watts, on light bulbs, for example, on your outlets. You measure watts with electricity, and that's what a watt represents. So watt represents joules per second. Everybody got the pencils figured out?
Yeah.
All right. We all good on pencils now?
Wait, how many joules per second?
Yeah, it's on the board, right?
But like how many?
How many? What do you mean by how many?
Okay.
Yes, those are the units. Yes.
Okay, see, okay.
Okay, so if you see watts, that's what a watt represents, is joules per second, 1 joule per 1 second. 1 watt of power is equal to lifting an apple up 1 meter in 1 second, because an apple is about a newton of weight. And so if you lift up a newton of weight in 1 second, 1 meter high, that's 1 watt. So 1 watt is equivalent to lifting a 1 Newton apple 1 meter high in 1 second. It's not a lot of energy. That's easy to do. But you look at light bulbs, and some light bulbs are 60 watts, some are 100 watts. Your brain runs on 20 watts of power. So it's incredible. You can't make a machine that's as efficient as your brain. It's amazing your brain can run such a little amount of power. It runs on less power than a light bulb does. Now, the whole human body, though, is going to run on more power than that. Yeah. In your body? In the brain? So there are a few things you can do. Increasing blood flow to the brain. Because when you increase blood flow, carries oxygen, carries sugar. And that's what you need for energy. You burn sugar to get energy in your body. And so oxygen is what you need to burn sugar. You need sugar in your blood. So if you increase blood flow to the brain, that can help. Increasing mitochondria, because mitochondria are the batteries in your cells. And so that's how you store energy. So if you increase blood flow to the brain or increase mitochondria, then you could increase your power. Yes. So the best way to do that would be exercising. That's how we do that. So this is not your brain, but if you were to run every day, because every day you are exerting energy in your muscle cells, your cells are calling for more energy. Your cells make more mitochondria and more blood vessels. Your cells actually create pathways, and they create blood vessels in your muscles to compensate for that. They make mitochondria in your cells. You get more endurance. Your brain is similar. Your brain creates pathways. When you learn something new, it makes pathways that become faster and stronger the more times you learn something over and over again. So that's why you practice. That's why you study, because you are creating these stronger neural connections between your cells in the brain, which makes you think faster and makes your brain stronger, basically. Yes.
So you said that exercising increases the blood flow to your brain.
That's right, and all over, yeah.
Does that mean that exercise makes you smarter?
Yeah, it does actually. Which it might be surprising to hear that, but exercise really does help with your brain health. It's important not just for your body, but for your brain. And so, yeah, it's very important when you study, when you learn, that you also stay active. It's not just to make your muscles strong, or it's a lot more than just that. But yeah, people who are not active are going to do worse when they get older, as far as dementia, Alzheimer's, things like that, depression. It's going to affect their brain more if they're less active. So being active, increasing blood flow throughout your body, is going to make you healthier all over, in all your organs, including your brain. Yes.
Does it also hear actions when, or for a woman, I guess, if you're active, when she's pregnant, she's gonna also affect the child?
It would definitely, yeah. I mean, it would if you are moderately active, not straining too hard, it's going to help the baby, because you're going to increase blood flow to the baby as well.
How would that not help it if it's too active?
If you are too active, you could cause damage to the baby. I mean, you could certainly hurt the baby if even roller coasters are way too much force for the baby to handle. So So if the baby, because the baby's swimming in fluid, right? And so that the baby hits against something over and over and over again, it's going to disturb the baby. Or a lot of force, like if you stop suddenly, that's going to hurt the baby too. Because babies are very fragile. And so,
If you jump on the trampoline without him, baby.
I mean, I don't. I would imagine if you did enough, yeah, that I would. If you're far along, and yeah, I would think if you did that for a long time and you're far along with the pregnancy, yeah, that probably would. Early on, I doubt it, but yeah, I mean, you can just tell. I think what the body can tell you when you're hurting the baby or not. I think, but yeah, I mean, you can just tell if you're overdoing it or not. But there definitely are things that would hurt the baby, like marathon running would be harmful to the baby. Things like that. Swimming is it's good exercise. So for a teenage boy, somebody who's growing, they might have a 2,400 calorie diet. So the amount of energy you eat a day in the foods, let's say you eat 2,400 calories a day. Well, calories is energy. That's how much you burn a day. So for somebody who's growing, they're going to burn that. If you're really active, if you play sports, it might be a lot higher. It could be double that or even triple that. Like Michael Phelps burns 10,000 calories a day. So he has to eat. It's just crazy what he eats a day. Michael Phelps, this Olympic swimmer. But so for a teenage boy who's an athlete, 4,000 calories a day easily. I mean, they're very active.
I saw Lifestyle's meal plan. It's like
Yeah.
3 burgers, 1 pizza in the morning.
Yeah, he eats a lot. I mean, because think about 10,000 calories is like 5 times what other people eat. I mean, 2,000 every meal. So that's 6,000 a day about. Yeah. So that's a lot. Well, to a certain extent it does. Okay, so if you eat a lot of sugar, that's going to be energy that is hard to sustain. That's energy you lose really quickly. You burn that really fast. So if you drink soda, for example, that's energy that you lose very quickly. But if you have something like protein or fat, that's energy that you burn over a longer period of time, and that's energy that you get for throughout the day. And so it does depend, because protein, especially early in the morning, is really good to eat because that's sustainable energy throughout the day. If in the morning, if all you have is say orange juice or an apple, that's energy you're going to lose very quickly. You're going to be hungry very fast. You're not going to have energy mid-morning. But having protein, which you burn throughout the day, is going to be more efficient use of calories.
Why is it that, like, one thing I've noticed, scientific or anything, but like when I eat more in the mornings, I tend to get more hungry faster.
Well, it depends on what you eat, though. What do you eat in the morning?
No, like if I have eggs for breakfast, I tend to get really hungry at like 10.
Compared to if you eat nothing?
Yeah, if I eat
Yeah.
nothing, then I'm fine to.
Yeah, I mean, because that partly is true. If you eat in the morning, you start your metabolism. It starts to run. And so without eating in the morning, you don't have your metabolism running as efficiently. Your stomach is smaller, and you might not feel hungry, even though you really do need to eat. So eating in the morning is important. Even if you're not hungry in the morning, it is important. You actually are going to not gain as much weight. Like people who are concerned about dieting might not eat in the morning because they feel like, well, I can lose pounds that way. But it actually just works against them, because going in the morning and you eat at lunchtime, your body has been starved for so long, it holds onto the calories very tightly when you do eat at lunchtime. You're going to feel tired and sluggish. You're going to want to eat more at lunchtime. And so you end up eating more throughout the day, and you hold onto the calories, and that turns into fat and stays in your body. So eating in the morning, you might feel hungrier if you don't eat enough in the morning, but it's better to do that than not eat at all. Yeah. So how does that work? Now, when you do eat though, is it a big meal? Or is it like a bunch of small meals? Because if you were to do that, but eat smaller meals and not have a big meal, that could work. But usually what happens if you don't eat for a while and you do eat, you get really hungry, you eat a lot, that's bad for your body. But if it's controlled where you eat a bunch of small meals when you do eat, that might help. But I don't know much about that, so I'm not sure how it's done. But not eating for a while and eating a big meal is not good for you. I know that much.
Yeah, for, that's from, because that's only 2,000 calories, but we try to do 6 meals a day.
Mm.
So,
Six.
yeah, so you like eat,
2,000
so you
calories.
eat something, no, that was for breakfast. So we eat something before the morning workout, after the morning workout, we have breakfast. And before lunch, you'd have like a snack or some protein bar, and you'd have lunch. Between lunch and dinner, you'd have something else, then dinner, and then something after dinner before you go to sleep. Because one of the things is when that's one thing for cutting weight. If you're trying to cut weight and you just stop eating, after a certain amount of time, your body starts freaking out, thinking that there's not going to be very much food.
Right.
So it just crashes your metabolism and holds on to everything it can.
Exactly.
If you're constantly feeding it, it's kind of like it's like if you're like saving up food for the winter and like you only get a little bit of food, you're gonna be really careful with your food. But if you're just constantly giving yourself, you're gonna do everything you can with it. So if you're just getting a ton of calories, your body just starts investing in muscle growth and other areas insanely. But one of the reasons that it's bad to starve yourself is because then it'll turn it into saturated fat and store it.
Yes.
And that's why if you're trying to lose weight by fasting, your body makes it unnecessarily hard because it's trying to do everything it can so you don't lose weight.
Mm-hmm. Yeah, that's exactly right. And that's why eating breakfast is important. And yeah, I mean, smaller meals throughout the day is definitely better for you than eating big meals, like 3 big meals compared to 6 smaller meals.
Robert, for you,
Yes.
I turn that off to genetic variation. To genetic variation. Maybe, with your body, you just wake up and then it waits to see if there's going to be food that day. And there it is.
No, I think that happens to everybody.
So it depends on the person. Not everybody's the same way. But yeah, a lot of people definitely do have what Robert described. That's true.
If I
Yeah.
have a huge breakfast, then maybe it's just a popular gene.
Could be. But yeah, I mean, it just depends on the person. But I know for me, I have to eat breakfast. I get really hungry if I don't. You know, people are also like that too.
Wait, so then is fasting not a good?
It's usually not good for you. No, usually fasting is not recommended, especially if you're growing. But if you're not, fasting is usually not a good thing to do to you, especially if you want to lose weight.
I think there are different
But
types of that.
there definitely are.
Which one's the
I
one
mean-
that they did where they try to put their body into the slow metabolism?
Yeah, that one video I showed you where he was eating reduced calorie diets, like 1,800 calories a day, I believe, or was it 1,200? I don't remember, but it was maybe 1,200, but it was definitely, yeah, it was a little bit more than half. So I guess about 1,200 would be about half. And you can, if you can train yourself to do that, you can, but that's not actually not eating at all. Like when you say fasting, you usually mean not eating at all. That's usually what they mean by fasting. If you eat small meals, that's very different from fasting where you have nothing. And so that can mean that too. It just depends on your term, but not eating for a long time is never good for you. Eating a reduced diet sometimes can help people in certain situations. You have to know how to eat the right foods because if you have a lot of sugars in your diet, you're not gonna be able to sustain that. But if you eat proteins and fats, you can help get a reduced diet from that way because those are more sustainable forms of energy.
Yeah, remember, if you eat in the morning, you're just going to feel more muscle mass. We need you to kind of
All right. So what I'm going to do is convert this into watts and see how many watts power a body during the day. So we know that, somebody eats 2,400 calories a day. That's how much energy they're burning. So if you are maintaining your weight, then you are burning the calories you eat. And so if you eat 2,000 calories a day and you're not getting any bigger and you're not losing your weight, then you are burning all the energy every day. And so for this person with a 2,400 calorie diet, if he is maintaining his weight, then that's how much he burns a day. Yes.
We're talking about kilocalories?
Yeah, this is kilocalories. I didn't really get into that, but if it's capital C, then it's kilocalories. Yes, capital C is kilocalories. So 1 calorie is 4,184 joules. We're going to convert into joules and then convert that to watts. Yeah. Oh, you already got it. Very good. 116 watts. Yeah, exactly right. So let's go one step at a time. So what did you do? Did you do this part first, Robert? We did 2,400 times.
I did 2,400 times 1,154, and I divided that by 3,600.
Very good. So do you know what this is? I just like doing this. We'll just do it step by step just to make sure everybody understands how to do this. What did you get for that first part? 41,600. Okay. So that's how many joules per day this person would burn with this diet. And then we're going to convert that to watts. Oh, 41,000. Okay. But we want to know how many watts. So we need joules per second to get a watt. So we have to convert this into seconds, joules per second. So 10,041,600 joules per day. We want to know how many per second he's burning. So we can divide this by how many seconds there are in a day. And we would do, so it's 86,400 seconds in a day. I think there's a song about that, isn't there? So driver's license. Oh yeah, I think there is. Wait, that's about years though. Seasons of Love, isn't that? Do they? They do. Yeah, that's right. Yeah. The Office is really good. So you divide this two, like Robert said, you get 116 watts. So for this person, 2,400 calorie diet, it takes 116 watts to power that person throughout the day. But it's really amazing though that, think about that. I mean, a light bulb is 100 watts and you can power the whole human body 116 watts. It's just amazingly efficient. Well, if you could harness the energy, that would be true. If you could, the body can't harness the energy of electricity from an outlet, but if it could, that'd definitely be true. Now, what's amazing about the brain, besides it runs only 20 watts of energy, it's about constant throughout the day. Whether you are thinking really hard about, physics, or whether you are just zoning out in front of a TV show, the brain energy is about constant. There isn't a huge difference in energy as far as the brain at rest or the brain at work. Yeah.
So then, is there like another, so then is the rest of the body just one?
That's right. To power the rest of your body, like your heart, your lungs, your blood, that's the rest of the body. Yeah. The brain is definitely, of the organs in your body, the brain is definitely the one that takes the most energy of all your body organs, because it's the most complex. And so yes, it does definitely hog the energy reserve of your body because it does so many things. It's so important too. And that's why you pass out if you don't have enough oxygen to your body. So if you hold your breath for too long, you might pass out. Why is that? Your brain has to shut down to preserve itself, because if it doesn't shut down to help run on lower energy, your brain will start to die off. But it does that to preserve the brain from dying.
So if we had battery powered,
That's right. You only breathe to power yourself. Yeah. You only breathe because you need to burn sugar. You breathe in oxygen to burn sugar and to power. But if you had power through batteries, for example, then you wouldn't need to breathe. Yeah. they're not sure about yawning. Now, it's possible that when you yawn, you're breathing in more oxygen. And if you take in more oxygen, you can be more alert. And so that might be possible because yawning brings in more air to your brain, and that might help it. That's one possibility, but they're not quite sure exactly why we yawn, but that makes sense to me. You do what? Yeah, I mean, that's usually, I mean, I think that might be why, but I don't know.
I mean, because teachers always like stop yawning, and then you can be like, actually.
Yeah, it might make you more alert. Yeah, it could. It might actually help you focus better. But if you make your brain, you know, if you bring more oxygen to your brain, or if you cool down your brain, you might stay more alert. Like, you know, they say that when you cry, you actually cool down your brain. So crying can make you feel better because for lots of reasons. One reason is that there's hormones in your brain that cool it down. And that makes you feel relief when your brain cools down. And so by cooling your brain down or bringing more oxygen into your brain, you can feel better, more alert, refreshed.
So is crying beneficial to your health?
It can be. Yeah. I mean, that's why we cry. I mean, because crying helps you feel better.
So
So
if you never cry, are you gonna be like,
yeah, if you never ever cry, that could be a concern. But you know, it depends on the person, of course. People are wired differently. Some people, you don't have to cry when you are born. But when babies cry when they're born, it means that they're breathing, and so that's important. But a baby can be breathing without crying. So some babies actually are born without crying, and they're fine. It's just, yeah, it's not normal. But some babies will breathe on their own. That's they're born, they're not crying. But most babies will cry, but or they just breathe really hard. I mean, they don't have to be crying to open their airways. But snoring?
Yeah. Okay, people who snore, like old people. My dad. Like, why do they snore?
It depends on the reason. Sometimes it could mean that they have trouble breathing. So sometimes it could mean you have sleep apnea. If somebody snores a lot and really loudly, that could mean a problem with their breathing when they're asleep. Do what? Doesn't have it? I mean, some snoring is pretty normal. Most people normally do snore a little bit. But if it's like really, really loud and prolonged and it wakes them up, that can be a problem. All right, I've got a few minutes to go before classes. Let me give you some things to work on before we end today. On page 264. I want you to do 9, 10, and 12 on 264 for today. 9, 10, and 12.
Put it under your torso because you want to keep your